All right, Piglet's Ditto is strictly vocabulary. These four topics that you see up here, we're going to prove in 2 weeks, but for now, it's just to grasp what they mean visually. So all of your answers are based on common sense, but they're not related to one another. So don't think increasing and decreasing is related to concave up or concave down. So the way this works is we start from the far left and we work to the far right when we get our answer. So from negative infinity to positive infinity, we have to determine whether the graph is increasing or decreasing. And literally that just means, is the graph going up or is it going down? So it starts in this first section here, and sometimes when it looks flat like this, it's never going flat. I won't give you any graphs that are flat. So you have to basically ask yourself, is this gradually going down or is it gradually going up right in this section? Answer? Perfect, going down. And it's going down the entire time until it gets to this asymptote. So basically, from the far left, which is negative infinity, to that asymptote, the graph is going down or decreasing. And the notation that you use right here is just like you did domain and range from Algebra 2, which you may or may not have remembered. So decreasing, we're just going to use parentheses from negative infinity to the x value of that asymptote, which is -4. So it's decreasing in those x values. So now that we've done one, here's what you need to remember. All of your answers in this section, they're always x values. Nothing to do with y values. All answers are x values. So now you go to the other side of the asymptote. And now, as you keep sliding left, is the graph increasing or decreasing in this section right here? It's increasing. It's going up. The graph's going up, and it goes up until it reaches this peak right here. So it's increasing from the asymptote, -4, to that peak, which is what x value? 0. Now, do you remember from Algebra 2 what parentheses means? Parentheses means, does it include it or not include it? I didn't like that answer. Did you like the way I paused? It means it does not include. What if I wanted to include it? What symbol would we use? We'd use a bracket. So parentheses means it doesn't include it. And in fact, it doesn't include infinity. It never does. You'll always use a parenthesis next to an infinity or negative infinity. And you'll notice we stopped at -4. We continued from -4. So at no time did we include -4. Well, -4 is the asymptote. It can't be increasing or decreasing where there is no graph. So that's why we had to use parentheses. And then when you get up here at this peak, it's not going up or going down. It's doing neither one. So that's why we used a parenthesis for 0. All right, so we continue from 0, and we can see the graphs increasing or decreasing in this section. Decreasing till we get to the bottom down here, this valley, which is what x value? 5. Now, you may have a critical calculus teacher who makes you use this symbol. It's actually a U without the tail, stands for union. I don't ever grade it. Mr. Cooper probably does, but he's kind of nerdy. But if you did do that now, it's a good thing. But if you ever forgot it and you used commas, I wouldn't mark it wrong. So we said it's decreasing from 0 to, you said 5? And then from 5, it increases the rest of the way. So 5 to positive infinity. So every single x value is accounted for there. All right. Let's do concave up and concave down, and keeping in mind that they're not related. Sometimes the answers look the same, but they're totally different vocabulary questions. So let me put up here a very common sense answer. If I gave you strictly a parabola, is that concave up or concave down? It is concave up. There's lots of different definitions and tricks that people use to determine whether it is concave up or concave down. How about an upside down parabola? That is concave down. Which means if I throw a cubic type curve in here, something like this, it's what? It's both. There's a concave up and a concave down section in that. I've basically combined these two graphs. Now, I've heard some teachers use this theory that if you were to literally pour water into this shape and it can hold water, it's concave up. Although I have no idea why holding water is concave up. If you were to pour water onto this shape, it would trickle over the side technically and fall off, and that would be concave down. I have no idea why, but I've heard that lesson before, Now, I've also seen this technical definition where if you were to choose a point on this side and choose a point on this side and draw the line that connects them, if that line you drew is above the graph in that section, then it's concave up. So what I drew is above this section, it's concave up. Where if I were to connect two dots in this one, and what I drew is underneath the graph, then it's concave down. And that was the one I was taught when I was in school. I think it's common sense. I don't think you need to do either one of those. Here's the reason why I don't like the water. Do you all agree that from here, this is concave down in this section? And somewhere it transitions to concave up. Here's an upside down parabola, here's a right side up parabola, so it transitions from one to the other. At that transition, which we're going to learn about what it is later, I'm going to provide a dot for you on the graph. If you'll notice, I've provided for you there. That is the location where it transitions from concave down to concave up, or vice versa. Here's my issue with the water, people. If you pour water right in here, doesn't it hold water? And holding water means concave up? Well, how high does it hold water if you keep pouring water into it? Like all the way up to here before it starts to spill out. But that's not where the concave up goes to. So I hate the water theory. But I think Mr. Cooper does it. Hopefully he's not watching this video. All right. So if we go back to this section, we start with a weird graph. And here's why I like the one I was taught. If I were to pick a dot here and pick a dot here, because I want to know what this section is, and I draw my line that connects them, my line is underneath the graph. And if my line is underneath the graph in that section, it's concave down. So concave down starts from negative infinity. Remember, these are always x values. And it goes to the asymptote, which is -4. Then if you go to the other side of the asymptote, this section is an upside down parabola. That's concave down, and we start from the asymptote and we go to the dot that I've provided. So we have back-to-back concave downs from -4 to that x value of that dot, which is 3. And then one concave up section that starts at 3 and goes forever. Did you love it? Hold on, I have to stop this.